Hi everyone, I just want to talk about the fact that this channel hit 10,000 subscribers this month. Thank you all for the kind words I received on my recent tutorial and on LinkedIn. There's a lot of positivity and encouragement. It was great to see. Since there's literally 5,000 more subscribers than last month, I thought it would be a good idea to introduce myself a bit more formally. So hey, I'm Yassine. I'm a published researcher in computational neuroscience. I've done research for a long while on learning, consciousness, and various internal state throughout my undergrad up until my master and until my PhD. So during my research, I was mostly in charge of the analysis, which I conducted in like MATLAB, Python, R, and I got very interested in machine learning. So let's check a few of these published research just so that you get the grasp about like what type of stuff I've done. Here's this one, brain network motif for a marker of loss and recovery consciousness. So we had like a kind of a protocol where we're anesthetizing people and we're trying to detect like their internal state. And the cool thing in this study is that we used like some graph theory kind of feature, which is like motifs. So when you have a directed graph, you can create like to calculate these motifs and count how much they are appearing and where. And it was a pretty good study, and basically we were able to detect emergence from like the unconscious state earlier than before. So that methodology was reused in a different type of paper throughout the years, because like how it works is that you have a core kind of research angle, and then like there's paper that are sprouting out of it as you learn more and more stuff. So this one is brain response to propofol in advance of recovery from coma and disorder of consciousness, a preliminary study. This one's actually after the other one, and it's a bit more advanced. And basically in this one, we were doing the whole flow, and then at the end of the day, we were able to get a what we call a reconfiguration index. It's like one metric that can summarize the image that we were seeing. I helped in most of these papers, but like here, this one is Charlotte and Catherine. They absolutely led this thing. And we're looking at this consciousness stuff in a different light. So this one is another one that's led by Danielle, a very smart woman. And what we were doing here is we were doing it on a disorder of consciousness patient, like on a case-by-case basis. And it's great because you can really see how different each of the brains are. And at some point, like we were like here, in this section, we were able to show that like this person, which was minimally conscious, actually, when you looked at their brain, they looked very much like a healthy person, and they emerged. So it kind of, all of these kind of aggregated together toward like, hey, let's use machine learning. Let's featureize that so that instead of us looking at it, it will be like a machine learning model that can predict the stuff. Then there's this other one that we published in our image. So a differential classification of state of consciousness using envelope and phase-based functional connectivity. In a nutshell, what we're doing is kind of the same kind of data set, but what we're doing is that usually people, researcher in consciousness, they were either using like the phase information or the amplitude information, including ourselves. But like if you think about it, you are taking only one part of the information and you're removing everything else, and then like either the phase or the amplitude. And we're trying to detect if like there was information that were in both, or like one was better than the other to detect in the exact same signal, which was pretty cool. Oh, there's this other study that I've done. Effect of transcranial direct current stimulation to an individual ability to learn a computer, to control a brain-computer interface. In a nutshell, this one was a bit hardcore. I was with a whole bunch of women from occupational therapy. They were awesome, very smart. And what we were doing basically is that we had like a very expensive piece of equipment that was able to like stimulation in the brain while recording. So this was cool, and what we're trying to do is like using a brain-computer interface, check if we were helping the stimulation of certain region of the brain, could we have the participant learn the control a brain-computer interface better. It's hard to control one, so I had no idea how to do any of this, but I was tasked with this. So it was all in MATLAB, and basically what I had to do is I had to make kind of a game where you can control it with your mind. If you think about like squeezing your right hand, I believe, and then not squeezing it, you can control where the ball was going. It was hard because I only had 1 month to set up this whole thing, and like you had to, like there was very little documentation. You have to get the data, right? You have to compute something, store it for future analysis, and then calculate whatever, shove it into the UI, and then like make the ball move and update the UI. There was a lot of different components, but there was a cool one. Basically, out of this, we realized that yes, if you stimulate, people in general will learn to control a BCI better. Then there was this one, assessing the quality of wearable EEG system using functional connectivity. It was a cool one. I got to play around with a few headsets that are super expensive. And then basically that's my head. And what I was doing is just like comparing a bunch of them and their quality. And the cool thing here is that it shows you how much a brain is different from one another. Like this is my brain, and you see, if you look here at the alpha power, I'm really skewed to the right. Here, this is me eyes closed, this is me eye open, and there's like way more power on the right than on the left. And this shows like across different resolution because there's less and less channel in here. Anyway, that was good. There's some of the headset were absolutely garbage. The Epoch Plus was garbage. So I played with a lot of different signal. One of them was there was EEG, yes, but also like physiological signal that are related to emotion. So in this thing, the article was wearable technology for detecting significant moment in individual with dementia. Long story short, we had like an Android app connected to a sensor that I was collecting data from, right? And I could do multiple things with it. I could like make music out of the internal state, but here we're collecting data and analyzing it afterward in people with dementia that was with their caregiver in kind of a session of dance and stuff. And we're looking at like, we're recording in different angle, like their physiology, but also like with the camera. And we're trying to detect like moment where something happened, right? And you could see it in the data also that something happened, even when people couldn't express it. Let's say people with like advanced dementia. One of the moments that was the coolest, I would believe, is like when someone with dementia like recognized somebody else, and we looked at the data and the feature that we calculated, and we can see it. And this is the caregiver that said she looked at me and her face lighting up. Something changed in her eyes, and she smiled at me. I don't know what to say. It's something you feel. I think it was recognition. She recognized me. She remembered who I was. Very cute. We got that on camera. We get that like on physiological signal. We get the report. Like that was awesome. So another one where I was involved in the analysis is electroencephalographic characteristic of children and adolescents with chronic musculoskeletal pain. I did a bit of analysis, and other people did like the whole bunch of others. And basically here is like there's children and adolescents that have this thing, that chronic musculoskeletal pain, like they always feel pain, and sometimes it's hard to know how much pain they are in, right? So the cool thing what we're trying to do is we're trying to, like with the other stuff, the emotional stuff and the consciousness stuff, try to get a marker that is unbiased, right? Literally with the EEG, and figure out like if we can with this have feature that we can shove to a machine learning model in order to detect the level of pain that these folk were in. A bit of a hardcore study because we were actually doing the pain, right? It's not crazy amount of pain, but like still, it's like tonic heat and cold pressure task. And I've done this. I was like in one of the control, and it's kind of difficult. Like you have to put your hand in like a very cold bucket and stuff. Yeah. But we did it for science. So here, this is the EEG signal. You could calculate the spectrogram, the power spectrum. There's a whole bunch here. Again, the motif that we were calculating. A lot of the stuff got reused in different research. That was cool. We were calculating the weighted phase lag index and directed phase lag index and constructing our network. So if we switch gear a bit, there's this study that I was doing during my undergrad actually. A feasibility study on the use of method of loci for improving episodic memory performance in schizophrenia and non-clinical subject. In a nutshell, we had, it was in a psychiatric hospital institute, right? And we were trying to find ways of like improving the memory of some patients, right? Without medication. And one of the things that I figured out is we could use the method of loci to help them like memorize sequences, right? And the thing was we were trying to make them learn like that type of stuff. So absolutely random image and or random words and whatever in sequence, and then have that and check their recall if they're able to do it. It looked like a lot, but actually with the method of loci, it's not that difficult to learn 20 items. And in a nutshell, method of loci is like you create this you leverage your spatial kind of memory to hijack it, to put these things into spaces that you know, let's say your house and whatever, in a path that you know about. And your brain is really good at this. So I tried it on myself and I was able to memorize like 150 items, something like that, like just random stuff. Yeah, that was a cool one also. Very hard on their brain, especially the clinical patient. The non-clinical subject, they were able to learn it really fast. Another study I did during my undergrad is this one. So the zinc fingers of the small optic lobe calpain bind polyubiquitin. This is another lab completely. And I came in like at the end of the study, and my part is just one component of it. And it was a molecular biology lab. So basically, the small optic lobes calpain is a highly conserved member of the calpain family expressed in the nervous system. So there's a variant of it. And if one is knocked out, like there's others that will be expressed. So the idea here is that we wanted to study this protein and then like what we call the zinc finger binding domain and its relationship with polyubiquitin, because this had a big role in memory. So to be honest, I was kind of in over my head in this study. I never did molecular biology before and I was thrown into that willingly. I did that. But it was cool. I learned a lot. And basically one of my stuff that I was doing is I had this protein and I was like cutting it up and then recombining it. So here, this is my stuff. They have multiple binding domain, and we were to say like, hey, is one of them more important than the other to like hook up with polyubiquitin? So I've made all of this different permutation by chopping up the DNA. It actually worked pretty well. This part of the study was easy. The Western blot part was super hard, man. Anyway, I think this one is mine. I remember this Western blot. It's a bit garbage, but like that's mine. Yeah, so I contributed to that thing. I'm also a tech entrepreneur. So during my PhD, I co-founded a company called Axia, which leveraged supply chain data to help industrial company make a better strategic decision. The company is going well so far. We have about 20 employees and we're growing. I'm in charge of a lot of different things, but more importantly, the AI section of the company. So the company is like it's a software that we built, and then this software is able to collect data from the supply chain of our customers and then like help them out with their own data. So basically, like usually the data is kind of dispersed, it's fragmented. So we jam our software straight up between the ERP and the supplier. And then with the different module, you're able to like structure the information as it goes, like putting plumbing in a house, right? So there's various modules. And what it does at the end of the day is that you can like gather all of this information in a structured fashion without too much problem. So for a manager, they can then see their supply chain information and then their KPI and whatever they want to track. Automatically, they were able to gather that for them. So I also absolutely love to learn and teach. This is actually something I'm quite passionate about, even more than machine learning, research, or entrepreneurship. I developed a passion for learning after one of my early life mentors showed me the book, The Brain That Changed Itself. It's a book about neuroplasticity, but I was hooked at this point. Since then, I've been like really pursuing a lifelong study of learning in all of the possible angle. This channel is actually one of my way of practicing and honing my teaching skill. So I mostly cover topics related to deep learning, as I find it like infinitely fascinating. If you have feedback, good or bad, about my tutorial, don't hesitate to post a comment. I read each one and try to make the content a bit better each time. I have a few more tutorials on the horizon, notably on foundational model, stable diffusion, the new movie gen model from Meta, a mixture of experts, and like 100 more on my to-do list. So that's all I wanted to say. Thank you everyone for the kind message, and see you in the next video.